So we got another maintenance to take care of today. Single family home. This unit is going to be a little bit different than what you guys have seen in the past. It is a package unit essentially, but it's something we call a BARD unit, and I believe that just comes from the original manufacturer of these typical kinds of units. It's a package unit that is wall mounted to the side of the house. So very common in this area. This is a flood area. Whenever we have not heavy rains or anything, but say we have storm surges and things like that, this area is known to flood. So these type of units were popular back in the day when they built these homes. So it's on the back side of the house over here. So I'm gonna go ahead and get my service maintenance bag, my maintenance box, and we're gonna get to it. All right, so there is our BARD unit. See, it says BARD on it there, huh? So again, it's a package unit. It's a lower half of it's going to be your condensing unit, your condensing fan, your condensing coil with the compressor on the opposite side. Blowers are on top. Evaporator coil is just above the condenser coil and the fan. So this one is probably, let's see if we can get a date. There's the serial number here. 09 is a good one. It's definitely not a 14, definitely not a 10, definitely not a 3. Yeah, so that makes the most sense. Maybe even 02, to be honest with you. This is a older piece of equipment for sure, but we're going to perform a preventative maintenance on it. We're going to check out the condition of the coils, the blower housing, the blower wheels, clean everything up, and just test the operations overall. We're going to go ahead and start with the refrigeration cycle. He's had the unit running here for a little bit, so we'll go ahead and check that out first and just see what we got going on. Quite noisy over here, but we got our refrigeration checks here, our valve for our liquid line and our suction line. We're going to go ahead and remove this panel here so we can access them and check the charge. On this package unit, temperatures aren't nearly as important, simply because superheat and subcool on a package unit is not typically something you're looking for, but we'll throw them on there either way. So we're going to go ahead and get our probes and our clamps. Now, I have serviced this unit in the past. I do recall it runs pretty hot. It is 410A. We should have some electrical components up in here as far as capacitor, contactor, all that good stuff goes. Nice and hot. Not as cold as it should be, but go ahead and take a quick peek here. Again, set our refrigerant cap somewhere we won't lose them. Suction liquid. And pull back on that probe. Shouldn't be too much of a loss, if any. Alright, so let's take a look at what our pressures are doing right now. Alright, so we need to set the right refrigerant, our 410A. Not getting a good reading because not good contact, but that's okay. But you can see that head pressure there, 453, man, that is awfully high. But again, this unit, I've worked on it for a couple of years. It is known to run at a high head pressure just because of the design of the overall. You know, you got that much surface area for it. the air is being pulled in through the backside over this compressor on that side of the system as well, being pulled through and then blown out. So it's not a super efficient method for exchanging heat, but it's getting the job done. You can see our our vapor saturation temperature. We got a vapor saturation temp of 41.9, 42 degrees. Not terrible. I mean, that very well could be running at 197 degrees, to be honest. Just the actual temperature on it. So again, we aren't really looking at superheat, subcooling. I mean, you got an idea on your superheat there, but it's not something you're typically looking at. So overall, the pressures are what they are for this particular system. It's really hard to get them dialed in. Ductwork's typically an issue. Poor return is typically an issue. And again, just overall poor exchange of heat on this type of unit. Again, the air is being drawn through the sides and then pushed across the outside of the coil versus our typical units where we see the air drawn through the coil and then rejected out the top. And you know, you got that on your standard package units and your split systems. Mini splits, they all work that way, but these BARD wall mounted package units draw through the side, blow out the front. And again, we're drawing air over the compressor, so another heat source. So we got an increase in temperature there to begin with, and then we're drawing air through the side here, and it's not a lot. It's not a lot of airflow. So that's quite a bit of a task for a system to reject heat that way, but that's again why we have that high head pressure of 449 psi. I know when they want to replace this thing at some point, we're going to be going with a different setup, more than likely trying to get a split system in there. So all right, I'm going to go ahead and pop some more panels for the electrical now that we've checked the refrigeration, and we'll check back in. All right, so off the bat here I can see we got a 60 amp breaker. That's going to indicate to me that we got a 60 amp breaker for the total unit. I'm going to take a wild guess that we got maybe a 5 kilowatt heater in this thing. So here's our electrical. We've got our terminal board here, our dual run capacitor there. We got a transformer, a single pole contactor, terminal spots for a high voltage, fan relay, and everything up top. This contactor should be for our heater kit. All right, so we're gonna go ahead and take some amp draws while it's running. See what we got. Again, we can go ahead and just check our high voltage supply, make sure it's proper, looking good. Not a necessity, but you know, system's obviously got 240, it's operating. But I like to be thorough, so why not? We'll just put it on the bottom tab there, top tab there, 246. Let's go ahead and take a compressor amp draw. 14.3 on our compressor amps. Let's go take a look at that nameplate real quick. Compressor 240, 60 hertz. Block rotor's 112, RLA is 15.3. All right, or 17.2, depending on what compressor's probably in there, but we're drawing pretty high amp draw, and again, it's just got more to do with the lack of heat rejection and lack of airflow across the evaporator coil as a whole. So we'll go ahead and take a look at our fan motor, which that should be it right there. 1.4. All right, if I had to take a wild guess here, go ahead and look at our blower. 1.7. We got 1.4 on the fan, 1.7 on the blower. 1.5 on our outdoor motor. So we're close. Indoor motor, 2.1, 1.7. So we're doing all right on that. All right, so I'm gonna show you now how we're gonna take a underload microfarad check. So this one's gonna be a little more difficult, only because it's a different kind of. All right, so our Our middle is going to be our common from the single pole contactor. Our yellow here should be our compressor. Our brown should be our fan. So 5 microfarads, 25 microfarads plus 20, so we got 40 total microfarads is what we're looking for. So we're going to do this under load. We're going to go ahead and put one of my gator clips here, another gator clip here, check our voltage, and then we're going to take that amp draw off of the same wire, 6.1. So we're going to go ahead and do a little calculation here. 6.1 times 2652 divided by our voltage, and that's going to give us our underload microfarad, 42. So we got a 40 plus 40 microfarad capacitor for a compressor, so it is working. It also looks new, so I didn't really have any doubts on that. Blower motor amp draw, a condenser fan amp draw, a compressor amp draw, and the only other amp draw we're looking for is the electric heat at this point. So we'll take that measurement here at the end. For now, we're going to go ahead and take the lock rotor amp draw. All right, so now that we got the system off, we're going to go ahead and take a lock rotor amp draw. So we want to know what the inrush amp is for this compressor on start. I'm going to give it a minute here to cool off for a second before we fire it right back up after turning it off. But it's important to check the lock rotor amp draw on the compressor because you want to see what the overall health is on start. If we are getting close to the rated lock rotor amps, 112 for this compressor, then we are getting close to that compressor locking up and failing. So we want to give that a quick check. And here we go. Now, most of your meters are not going to have this inrush feature. This is something I like about the field piece multimeters. They always seem to have that one on there, even on their cheaper ones. But this is by far field piece SC480 wireless multimeter. This is one of my favorite multimeters I've ever had. So it's sizable, it's good, it's easy to get into places. It's got a backlight, again, a wireless feature, lots of different features on measurement checks, and that inrush, which I like quite a bit. So here we go. Oh, that's not going to quite work. So we're going to have to wait for that time delay on that thermostat. He must have the thermostat wired for power from the unit. So killing the power to the unit effectively sets a 5-minute trip on that start. So I'm going to go ahead and stop the video for now, and once we get that lock rotor amp draw, I will take a look at that. So just something to show here. I don't like dead time. I don't like standing around waiting for time delays to kick on and whatnot. So if there's something I can do in the meantime, I do it. So I know that once we get done with that lock rotor amp check, all my measurements for the most part outside of the heater have been checked, and I'm going to want to clean that condenser coil, clean that evaporator coil, take a look at the condition of the blower wheel. I don't believe it's going to have a capacitor, but we'll check. Actually, it should have a capacitor, but it should be up there with the blower. So we'll check that. Check the drain pan, clean it up. I got to grab my wet vac so we can vacuum out his drain line here, make sure we don't have anything clogging up. Yeah, I don't like dead time. So while I'm waiting on that, because I have that inrush feature on my multimeter, I don't have to sit here and stare at it and wait to catch that load intake. What I can do is go ahead and get myself prepped for the maintenance side of this, the cleaning side of this. So got a nice water hose here that we're going to get going for the condenser coil cleaning. I'm going to go ahead and get all my stuff for my actual maintenance of the blower, the evaporator coil, and the drain pan ready to go. So we're going to throw some algicide tabs in there. All right, we got to start. Overload. So we got a high amp draw, higher than the meter can register. So no bueno for that compressor. I would at this point recommend a hard start kit for the compressor just to help with that initial kick. It also helps with the electric bill, and it will also extend the life of that compressor. So just like on another maintenance we did yesterday, a hard start kit would be recommended for this compressor. So I'm going to go ahead and get the system off, get in position to clean everything. I'm going to remove some panels so I have better access to the equipment, and I'll check back in once we get there. All right, so the only panel I've not removed is the front grate for the condenser coil here. I'm going to be spraying that from the inside out, so I don't really need to necessarily remove that unless we have some chunky stuff coming out. But as you can see, we got our blower wheel system here set up. It's similar to what a mini split kind of looks like, or a pancake unit, where you have a couple blower wheels with a center mounted motor with 2 shafts on either side. I know you guys haven't seen that quite yet. Here's our capacitor for it. We're going to check that. And then on top of that, we got our evaporator coil. Looks like they got a UV bulb here that's burnt out, so we'll make a recommendation on replacing that if they want to keep it. But here is our evaporator coil. Now, with our blower system under our evaporator coil, we effectively have a positive pressure system. So air is being drawn through the house right here through our returns. You can see what I mean when I say there isn't much airflow through the blower housing and then out through the evaporator coil. Now look at that drain pan. That's nice. It's mostly rust, not a lot of buildup, so it's not terrible, but needs a good cleaning either way. So, all right, I don't know if you can see that now, but there's the bulb, drain pan here. So we're gonna throw some algae tabs in there, clean it up, throw a little water down it. Coil's not terrible, but we're gonna disinfect it and clean it as well. Blower wheels themselves have a pretty good amount of buildup on them, but with the age of the system, I don't think it's really worth the time to pull and clean those. I know that he's looking to replace this at some point, but this is what your BARD package unit systems look like opened up. So we're gonna go ahead and get some drain tabs and evap rinse here, and I'll just do a little time-lapse video on that. All right, so we went ahead and disinfected the coil, treated the pan, added some algae tabs, flushed it after brushing it a little bit, and it's not too bad. So we're gonna go ahead, and it's draining over here. So I'm gonna go ahead and button everything up so I don't get any residual water. Actually, real quick, we're gonna go ahead and check that capacitor. So we're gonna flip over to our microfarads. That's another reason why I recommend you get a meter with a, well, 1, with a microfarad measurement reading feature, and 2, a magnet. All right, so we're gonna test. This is a single run capacitor for the fan or the blower motor. So we're gonna go ahead and just check the microfarads on it. I don't see what the rating is on it, but looks like it's installed backwards. So let's see if we can read that real quick. I was reading 3.3. 5 microfarads, so plus or minus 3%, so we're almost 50% low. I'm gonna recommend he replaces that. With the low reading like that, we are running the risk of having a failure on the blower motor startup, so he really should replace that. We're well outside of the 3% margin on that. So all right, now that we got that going, I'm gonna go ahead and button the system up, clean up my cleaning supplies, and then we're gonna do a quick clean on the condenser coil. All right, so we're gonna go ahead and clean this coil out. Best that we can anyways. All right, so we're gonna go ahead and get that thing buttoned back up. I think we're good to go on that for now, and we're gonna go ahead and wrap this thing up. I'm gonna make my recommendations, and we'll go from there. So check back in with you at the truck. All right, so we did that quick BARD package unit maintenance. System had pressures of 122 over 460. Like I said, I've got some history with that unit, so it's always had high head pressure, just simply because of the circumstances, type of unit, the way it's installed, the area, it's older. I did make a recommendation for his compressor hard start kit to help kick that thing on initially, hopefully drop down the initial amps on start, as well as possibly help with the run. So we'll see if that does that. He went ahead and okayed that, so we'll get that for him. Also recommended he replace his single run capacitor for the blower. He said okay to that. And then he also had a UV bulb that had been burnt out. He said been there for about 4 years, so even if it wasn't burnt out, it isn't producing UV after 1 to 2 years depending on the style of bulb. So we're going to go ahead and replace that for him too. So all in all, his system's up and running, nice and clean, doing its thing, and we'll take care of him later this week with those recommended part replacements. Nothing too out of the ordinary, nothing too difficult, and it should benefit the customer as well as me, and that's what we're trying to do here. Is I can make money and I can help them. That's kind of how this works. So now we're going to go ahead and get ready for a package unit maintenance. Yeah, so it's not going to be too much different than the BARD system, but I'll go ahead and take you along with me on that. All right, here we go. So we got our package unit here. It's a 4-ton Rheem Classic. I actually replaced this system in 2020, so about 3 years ago, so it's about 3 years old. Not a bad install, if I do say so myself. All of our electrical equipment and everything's going to be on this side here. Well, nope, actually no. So that's where all the wiring happened, but I believe I can't access it from the front. So yeah, electrical panel in the front here, drain line, evaporator coil. I got some water leaking out of the cabinet there, so I bet that thing's clogged up. Oh yeah, you can see water down in there under the pan. It looks like it's clogged, so I bet if I take this thing off here, oh yeah, look at that. Oh yeah, look at that nice stuff. Oh yes sir. Gonna need a maintenance. All right, so we're gonna go ahead and open up the electrical. I'm gonna go ahead and open up the evaporator, take a look at that. Gonna get that pan so we can clean it out, but I want to jump start this unit because I don't have access at the moment. The homeowner is not home, so I do not have access to the indoor thermostat. But that's okay, because we're gonna jump it out. Ooh. Ooh. Uh-oh. Slime. That's been happening a while. Oh yeah. Oh yeah. Look at that. Gross. I bet the whole cabinet inside is flooded. Awesome. All right, well, probably gonna pop the top here, take a look at the coil on that side. We gotta get access to it anyways to disinfect it. So we got our 45+10 capacitor, fuses for our heater, 2 heat sequencers, so at minimum it's a 10 kW, possibly 15 kW. Sweet. Single pole contactor looks good. Transformer looks all right. Wires for our UV and our blower housing and heater. So let's go ahead and jump this thing out and get some measurements going. So we're going to do this by jumping out our cool, our fan, and our power. I probably need to pull that whole pan. I gotta see if I can do that. Still doesn't look like it's draining right. All right, I gotta do this correctly. There we go. Pretty sure I can pull that whole pan, so we're gonna do that. Let's go ahead and take some measurements first. Sounds like a loose Schrader. Slightly loose Schrader. All right. Meter. Low on the bottom, high on the top, makes sense, right? All right, so while I let the refrigeration do a cycle, I'm gonna go ahead and take some measurements like our capacitor under load, our compressor run, fan run, and blower run amps. See what everything looks like. So let's go ahead and start with blower is pulling a 3.4. Indoor blower 6.0, so we're looking good there. Let's run off to our fan. Oh, sorry, that's gonna be our compressor. 12.4 on the run. Where you at, compressor? 21.2, so that's looking good. Our fan. 1.5, 1.9. All right, let's check this capacitor under load. So we got a 45 plus 10 at 6% plus or minus. So let's see, this will be our common side and our compressor side. Careful not to get electrocuted. Now let's take that compressor amp draw and let's do a little bit of math here. Whoops, not that yet. All right, so we got 6.4 times 2652 divided by our voltage at 380. 44.6 to 45 microfarad capacitor. We're looking good. All right, now let's go ahead and take a peek at our refrigeration cycle. .43-degree coil, 17 degrees of subcool. Superheat is low, but again, we're dealing with a package unit here. We got a head pressure of 318. So I'm gonna say check, check, check. All looks good. All right. Got that in place. All right, so I'm gonna go ahead and power this thing down so we can take a quick inrush. Oh yeah, inrush amp draw on our lock rotor. And we'll see what that looks like. Now this is going to be a Nest thermostat, so it's definitely going to have a time delay. But just in case, for some reason, we'll go ahead and put the inrush on. Flip it back on. We're jumped out. I forgot. We're bypassing thermostat. Lock rotor overload. So we're gonna go ahead and recommend a hard start kit for that compressor. All right. Go ahead and shut her down again. So I'm gonna go ahead and work on getting that pan out, the top of the unit here off, so I can access the evaporator coil for disinfection and just checking everything out, including the blower, and see what the bottom of that system looks like, because with water all the way over here and that drain having been clogged, I can bet that that whole bottom cabinet is filled with water and slime. So let's take a look. Last time I was here, there was about a 4-foot iguana up there. That's always a good sign that the insulation's pulled. So I'm gonna recommend some new insulation for that. Would you look at that? See if we can get a better look at that. And water, a few inches of it. I don't know if you can see that down there, but man, that is gross. Oh boy. Yeah, we got to get that cleaned out. Coil though, not too shabby. UV bulb. It's older than 2 years, so I'm gonna recommend a replacement on that. All right. See if we can get some of this stuff out. I have these wands I used to have for this vacuum, but I've since misplaced them. And I reminded myself on the last maintenance I need to buy more because they're awesome. Oh yeah. Nice and caked.
Oh, that's gross. If I had my wand, I could really get in there good.
Alright, there goes the battery. So I'm gonna go ahead and change this battery out so I can keep cleaning this up, and we'll get back to it here shortly. Alright, so I forgot I had this little wand here, so that'll help. Still gonna see if I can pull this whole pan out. So this is above and beyond the maintenance. This is a deep cleaning here, trying to resolve a problem, but I know these people, so we're trying to help them out a little bit.
Alright, it's gonna take me a hot minute, so.
I'm gonna go ahead and get back to recording once I get this thing more tidied up. Alright, so for now it's gonna be the best I can do without pulling everything out of here to get that out. So for now, that's where we're gonna leave it. I'm gonna talk to him about doing a much deeper clean on this here in the near future, and we'll try and get much more of that out. But for now, it's a lot of progress, so gonna go ahead and do some disinfecting as well as pan treatment. Heavy for this one considering what we have found. Bulbs burn out, so I ain't worried about hitting it. We're gonna replace that. Alright, so I'm gonna go ahead and do a time lapse on the rest of this clean. Get the water hose over here, spray out this coil a little bit better, take the top off that, spray out the indoor condenser coil, or sorry, the outdoor condenser coil from the inside out, get that nice and cleaned up, and then test the heat, and we'll call it a day on this. But we got to address that stuff and see if I can pull that pan out for now. So all right. All right, so unfortunately, I am not going to be able to wash out this condenser coil. I don't have access to water. That water hose is broken, so I won't be able to use that to wash it out. So I'm gonna go ahead and button this thing up. We're gonna have to return anyways for the cleaning of the extensive cleaning of the base of the unit over there. So what I'm going to do is just get a working nozzle for that in the meantime, and when we return we will clean that out. So overall the health of the system's good as far as at least the measurements go. I will recommend a hard start kit for the start of the compressor, a UV bulb. It is glowing, but I know it's older than 2 years, so it's not producing UV anymore, so we'll go ahead and replace that. And then a deep clean for the bottom of the unit. So I'm gonna go ahead and tidy everything up, wrap it all up, and call it a day.